Hi there. My name is Matthew Holmstrom, and I did my Do Something and Report It project on inflation alternatives. To be more specific, I did my project about lower income alternatives. So basically, inflation alternatives that like lower income houses could use if they can't afford conventional inflation. And some examples of these would be newspaper, clothing, sod and dirt, plant material, cardboard, wool, hemp. So a lot of different things that are either a lot cheaper than conventional insulation or that you can get for free pretty much anywhere. Now, the purpose and use of insulation. As we all know, insulation is used in the walls, in the attics of our homes for heating and cooling. And insulation works by slowing the conductive heat flow. So it basically keeps the hot air from moving. So it'll keep the hot air in your house in the winter and the hot air out in the summer. This picture is sums up pretty well why insulation is so useful, because you have so much airflow through your attic and your recessed lighting, through crawl spaces, electrical outlets, and vents. And so the overall purpose of insulation is to reduce our energy use, because when it comes to heating and cooling, it accounts for about 50 to 60% of our energy consumption and about 35 to 45% of our energy costs. So the purpose of insulation is just to reduce our overall energy use on a household basis. Now the way I did this is I built a wooden box out of 5/8 inch thick plywood, and it was about 15 by 15 by 15. I taped a wireless thermometer to the lid, and I taped it on a little piece of twine so it would hang down basically in the center of the box. And so yeah, I taped that on there, and it was a wireless thermometer. You can see the other end of it right down here. It would tell me what the temperature is. I wouldn't have to open the box or anything. And I would put this entire box in the fridge, which worked really well because the fridge was pretty much constantly 42 degrees Fahrenheit. I then took temperature in, I took the temperature at 10-minute intervals. And to start with, I just did the box completely empty. And then the different types of alternative insulations that I used were newspaper, clothing, and dirt. And I also did conventional insulation just to do a comparison to how well these things work towards it. And one of my problems was I had to kind of dig a little hole, or like put a hole in the insulation for the thermometer to slide through, because otherwise the thermometer would just sit on top and it wouldn't work very well. It wouldn't function as it was supposed to. So I tried to get the thermometer in the middle. And you can see throughout this experiment I had some very curious cats looking in. So these are this is my data for this experiment. You can see how fast the temperature changed. The starting temperature was 67 degrees each time, just as a heads up. The temperature changed pretty rapidly when the box was open. It took about 80 minutes for when it was empty for the temperature to reach 42, and about 90 minutes for both dirt and newspaper to reach 42. Clothing took about 110 minutes, and conventional insulation took 150. Now, if you're a more visual person, I also made a graph, and you can see, like I said, that newspaper and dirt were just a little bit better. It looks like overall dirt might have been a little better than newspaper, but in the long run, they reached 42 in around the same time frame, maybe 5 minutes off, because like I said, I took it at 10-minute intervals. And then again, you can see clearly that clothing did the best in terms of alternative insulations, and then of course insulation did the best because it's what insulation is for. So in conclusion, conventional insulation clearly worked the best. Dirt and newspaper were about the same, both being slightly better than conventional, or than, sorry, that should say, than nothing. But the best out of the three alternative insulations was clothing. Now, the purpose of this experiment, again, I mean, insulation does have to do with energy use, but with lower income families, a lot of times they're not focusing on that because they have bigger issues to worry about. But when it comes to needing insulation, not only to stay warm or to stay cool, but also to help with your energy bill, a very cheap alternative would be clothing. It's something that you can just go pick up at Goodwill, or you can get from a donation center. So for a lower income household, this is a feasible alternative if they have nothing else. And it's also a decent alternative for the fact that conventional insulation is now being viewed as more hazardous to human health and the environment. Now, if I were to do this whole experiment again, I would probably seal the box, or I could also actually do two sets of trials, one with the box sealed and one without it sealed, to see how much of a difference that would make. I'd also use a wider variety of materials. Like I said, I could have used some of the things I mentioned earlier, like plant-based and hemp and stuff like that. It probably also would have been a little more effective to use maybe a different kind of wood, or to put shingles on it, or drywall even, so you have something closer to what you would actually be using this insulation in. And I also feel like this experiment would have worked better with a bigger box, but then I would have needed a bigger fridge. But like I said, the overall purpose is insulation is supposed to help reduce our energy use. And for lower income families who can't afford conventional insulation, clothing materials are a decent alternative. Thank you very much, and I hope you enjoyed my presentation.